Welcome to the VTC course on Java 6 programming. This tutorial assumes that you already know how to write programs in Java. Now, that doesn't mean that you need to be some kind of super Java programmer. It only means that this course is not about Java basics. You only need to know how to compile and run simple Java programs. This course is here to show you how to use some of the newer things in the language. My name is Arthur Griffith, and I've spent several years as a programmer. I turned into a writer and a teacher of computer programming. I've written several books, some of them on Java programming. Now, this course is filled with examples. These are all small programs, each one written to demonstrate just one thing. By the way, all the code that I'll be showing you compiles and runs and is available to you along with this course. Now, to keep the display of source code simple, you'll notice that I use a simple text editor. Now, I'm not trying to sell you on the idea of using any particular editor. You can use any editor or any integrated development environment you prefer. They all do the same things. It doesn't matter which one you use. The Java language is the same. The course starts out with a bit of a review of things that you may not use very often. Things like abstract classes, annotations, default constructors, and so on, and then goes on into an overview of swing. Swing is a huge subject and could take up the whole tutorial, but I will show you just enough of it so you'll be able to write applications. You'll learn enough of the basics of swing to be able to easily pick up any other parts of it you may need. There's a lot of it, but it all works pretty much the same. I'll be showing you some of the user interface items that can be used to add professional touches to your software. You'll be able to add toolbars and those little pop-up tool tips to your application. Oh, here's something slick you can do now. I'll show you how you can dynamically change the look and feel of your application. Generics really came about in Java 5, but they were expanded a bit in Java 6. At any rate, I'm going to explain them as if they were brand new because not everybody's used them. Java is big on collections now. The collections are objects that can hold other objects for you. They have the power of organizing things in ways so you can get them back the way you'd like to have them. The lang and util packages have some things in them that you may not be aware of. I'll show you what I mean. And there are some special things that you need to be aware of. Things like timers and sound and the keyboard and internationalization. And there are some new I/O classes that you may not have even heard of. And I'll wrap it all up with some gotchas. There are a few things in Java today that can sneak up on you if you're not careful. I'm certain I don't know about all of them, but I'll show you a few that I do know about. You already know how to program Java, so you'll already know about some of these things, but I want to give you an overview of what you'll find in Java 6. Just like with the previous versions of Java, the principal software product is the Java Standard Edition, also known as the Java SE. It's made up of two parts. The runtime environment is known as the JRE. It includes the libraries of executable code, these are the classes that make up the runtime libraries, and the Java virtual machine. Everything, in fact, that you need to run a Java program. These things are what makes Java so portable. The Java Development Kit, known as the JDK, is the compiler and debugger that can be used to develop Java programs. Actually, the JDK includes the JRE, so there is no real difference between the JDK and the SE. You'll see the names used almost interchangeably in the Sun documentation on their website, so don't let that throw you. The Java Virtual Machine is a program. There are versions of it that run on different computers, such as Apple, Unix, and Windows. The JVM, or VM if you prefer, executes compiled Java bytecode, so the programs are all completely portable. The JVM from Sun is also called hotspot, and it has two faces. The client VM is for platforms typically used for client applications. This version of the VM starts more quickly and uses less memory than the other. The server uses more memory but executes faster. Other than the optimizations for size or speed, the two JVMs do exactly the same thing. You can specify which JVM you want to run whenever you start the program. You can specify either the client or the server on the command line. If you don't specify, the default is the client. The examples in this course are run with the default. Actually, the example programs here are so small, it doesn't really make any difference. Those are the two basic tools. I will be showing you lots of examples of using the Java compiler, and I'll be showing you lots of examples using the JVM to run programs. But there are some other tools that you need to know about. You need to at least be aware of their existence so that you'll know what you have available to you if you want to use them. This program has been around since the first days of Java. It reads the source code and uses the code and the comments it finds to generate documentation. It does an amazingly good job. The documentation that you'll be using to figure out how to apply the Java system libraries was generated using JavaDoc. The really neat thing about doing it this way is that you can be sure the documentation matches the actual code. When you make a change to the code, the documentation keeps up. This is sort of a special purpose web browser that's used in the development of Java applets. It will read the HTML of a web page and execute any Java applets found in it. If the applet viewer executes an applet successfully, any Java-enabled web browser will be able to execute it also, so you don't need to test a bunch of browsers. The jar utility can be used to create and maintain jar files, which are the files that contain libraries of executable Java code, and also data files of various types, including image and audio. The files are compressed to save space, and you can digitally sign them if you need to. JDB is a command line debugger with a simple interface. There are several ways to use it, but the simplest is probably to type JDB on the command line to run your Java program the same way that you would use a regular JVM. You can write native functions in C and call them from your Java program. The java6 utility reads the code of Java classes and generates C code that can be used to build the interface. JavaP is a decompiler. It doesn't return the class file to its original source code, but it does extract the essentials, the class names and the method names, and it can display the bytecode that makes up the executable portion of the class. EXTCheck has to do with installing extensions to the versions of Java you have installed on your machine. Any new extension you intend to add will be checked against any extensions that you may have already installed to make sure you get the latest version. And that's not all. I counted 25 more programs listed under Tools and Utilities, and 8 more experimental. If there is something you need, check with the java6 documentation because it probably exists. One of the fundamental characteristics of Java is that it is portable. You compile your program as a collection of class files, and your compiled program will run on any of the several platforms. It will run on any computer that has a Java runtime environment installed. Sun provides a JRE for its Solaris operating system as well as for Linux and Windows. Other companies provide Java runtime environments. You'll find them on Macintosh and AIX and many others, including cell phones and DVD players and so on. Java is everywhere. This lesson is about Java types. Now, you are familiar with the fundamental types. The fundamental types can be used in your program, and you can stick values in them, but you can't change the types themselves. They are what they are. The Boolean type can only assume one of two values. It can be assigned the value of true or false, and it can be used in a conditional expression to test which it is. The byte type is an 8-bit signed integer. The short is a 16-bit signed integer. The char, or char, however you want to say it, is the only unsigned data type in Java. It's a 16-bit unsigned integer, and you can do arithmetic with it, but it's always interpreted by Java as being a Unicode character. I have some more information on Unicode in an upcoming movie. The int is a 32-bit signed integer. The long, a 64-bit signed integer. Floating point numbers are either floats or doubles. Doubles are twice the size of floats and have a larger degree of accuracy. Almost all floating point arithmetic is done with doubles these days. Floats are smaller and they save space when storing large amounts of data on disk, but that's about all they're used for anymore. When you declare a location for storing an object, you are declaring a reference. A reference is a pointer, even though a lot of people don't like to think of it that way. And you can't do arithmetic with the contents of a reference. All you can do is store addresses. There are 4 types that you can program. These are types that you can define to contain whatever you want them to contain. The first and foremost of these types is class. Writing a Java program is fundamentally a job of defining classes. For a Java program to run, it uses the class definitions to create objects, and the objects contain all the instructions to make your program do things. This is an example of a simple class. It contains a variable, and it contains methods that can modify and return the value of its variable. This is an example of a class definition being based on another class definition. The circle class extends the figure class by inheriting all of it and adding a few things of its own. The figure class is the superclass, or the base class, or sometimes called the parent class. Nothing of the superclass is lost when it's extended this way. It's all inherited. An object of the circle class is also an object of the figure class. An object of the circle class can be made to masquerade in your program as an object of the figure class. Such masquerading has the fancy name polymorphism. This is an abstract class. Notice that it has a method named getMaximum that doesn't have any code. That makes it an abstract method. The method is incomplete. Therefore, the class is incomplete. Now, you can't create actual objects from an abstract class. You can only use such a class as a base class to construct other class definitions. There are 3 things that will make a class abstract. You can put in an abstract method, as in this example, or 2, you can extend an abstract base class and not implement the abstract methods, or 3, you can implement an interface but not implement all the methods of that interface. Speaking of interface, it's the second of the 4 types that you can program. An interface is defined about the same way a class is defined, but all the methods are abstract. This is an interface definition. It looks like a class with method definitions, but none of the methods have bodies defined for them. They're all abstract. You don't have to use the keyword abstract with an interface because everything is always abstract. An interface is used like a contract. It's sort of an unbreakable promise. If a class implements an interface, it's guaranteed that that class has an implementation of all the methods defined by the interface. Otherwise, the class is abstract and can't make objects. The next type that you define is the enumeration. This was a later addition to the language. The addition of the enumeration type did not add a new capability, it only added optional syntax for doing something that could already be done. Here's an example of a simple enumeration. Declaring a simple enumeration is not much more than specifying a list of names that you can use to tag things. It works when you have a small set of known possible values. This example shows how you can define a list of names, then use an enum variable to hold one of them. Later in this course, I'll be showing you how you can add values to the symbols and how they can be used in if statements and for loops. The last of the types is the annotation. An annotation does not cause any executable code to be included in your program. It only adds descriptive information that can be accessed by external processes wishing to find out information about your program. I'll have some examples of doing this in a later movie. Constructors. Every class has at least one constructor. Some have more. Whenever an object comes about, it comes about from a class definition, and one and only one constructor is called to initialize the object. Here is a simple class with two constructors. Now, when you call a constructor in the creation of an object, Java looks at the type of arguments being passed to the constructor to determine which one to use. This first one, the constructor without any arguments, is known as the default constructor. Of course, you know all of this. But there are some other things, some hidden things about constructors that you may not know, and they can be important. Here is the same class with a slightly different name. Other than that, it's exactly the same. Notice the call to super that's been inserted at the top of each constructor. It's actually always been there. If you don't put in a call to super, the compiler inserts one for you, and it's always the first line of code. You can't call the super constructor from anywhere else. The automatic call to super is always a call to the default constructor of the super class. If you want to call a different constructor, you will have to do that yourself. Look at this example. The sphere class extends the circle class that we looked at before. The default constructor of the sphere class only calls the default constructor of the superclass, the circle class, to set the radius to the default of 1. However, the sphere constructor that accepts the radius value as an argument uses a call to super to set the radius in the superclass. Notice in this example the default constructor doesn't do anything. All it does is call super, even though you can't see the code. Now, if you define a class that doesn't have a constructor, you'll get one anyway. A default constructor is automatically generated for you. You always have a constructor. On the other hand, if you define one or more constructors and don't define a default constructor is not generated. That is, if you define any constructor at all, you won't get the automatic generation of the default constructor. Just remember this, you always have a constructor. If you put one in, Java won't. Also, the first line of code in every constructor is a call to super. If you put one in, Java won't. Occasionally, you'll see something like this, a class with a protected constructor. Sometimes you'll find a public constructor along with it, and you can use that, but sometimes you won't. This means that you can only use the class as a superclass and extend it because only a subclass can call a protected constructor. It often means that there is a method call somewhere that you can make to create objects of the class. It's really nothing more than a sort of sneaky way of writing an abstract class. One of the first things that you run into when you start programming in Java is the keyword static. But it's not always as well understood as it needs to be. Once you understand how static fits in the overall Java scheme of things, you'll find that it can be a very useful tool. But to understand static, you need to understand how some other things work. As a Java program runs, it constructs objects to get things done. To construct an object, it needs a blueprint for the object that it's going to construct. Such a blueprint is a compiled class. So the first thing that happens is that a class definition is loaded into memory. Loading the class definition is a complete step, but normally precedes the immediate construction of an object from that class definition. Now the object is ready. Its constructor has been called, and the object is ready to do work. When the object is constructed, any variables that were defined for it were included in the construction, and they now exist. If your program decides to create more objects, it will do so using the same class definition it loaded before, and it will create new variables for each one. One class, many objects, with variables for each object. Now that's the normal way of doing things. But with a static variable, it's slightly different. The variable is fully defined in the class and ready to go as soon as the class is loaded. No object is necessary. The variable is located in the class and ready to go. Adding or deleting objects has no effect on the variable. It is completely defined in the class. There is never more than one copy of it in memory. All this just because the keyword static was used when it was declared. Methods are a little different from variables. All executable code remains with the loaded class definition, but normal methods require that an object exists before they can run. When a regular method runs, it contains a reference named this, which holds the address of the object. It is through the this variable that the method has access to all the variables of the object. That is, whenever your code refers to a variable, it is necessary to specify which object holds the variable. If you don't specify the object in the method, the default is to use the this reference that was supplied to the method at the time it was called. On the other hand, if the method is static, it can only refer to the class, so an object specification is not necessary. Just remember, regular methods have a reference named this, and it uses that to resolve names. Static methods don't have a reference named this. The result is that you can call a static method by referring only to the class name. It doesn't need an object. The import statement in Java is the cause of some confusion. The reason it's confusing is that it looks like one thing when it's actually another. In fact, the import statement could be the most misunderstood thing in Java. It's confusing mainly because import was such a poor choice of a name. When you think of importing something in software, you think of loading something from disk into a program, but that's not what the import statement does. Now, I'm going to list 8 specific characteristics of the import statement. These 8 things describe everything that import does. The import statement provides full names for things that you, in your program, only call by partial names. That's really all the import statement ever does. In reality, you're never required to use an import statement to write a program. It's only there for convenience. All it does is tell the compiler the full name of something that you call by a short name. If you always use the full names of everything, the import statements will simply be ignored. You can always use it to provide the full name of a class or interface from the Java library. For example, this import statement will allow you to call the class by its short name, image. The compiler will look at the import statement to find the full name. You put in a statement like this: Then the compiler will look in a directory named Java with a subdirectory named AWT for a class file by the name of image. If that doesn't work, the compiler will look on the class path for the same set of names in a jar file. The point is that no matter what is written on the import statement, nothing happens until the short name is used in your program. You can use an asterisk in place of the class or interface name and include all the classes and interfaces that are in the same directory. For example, this import statement can be used to resolve the name image, but it will also resolve rectangle, button, canvas, color, lots of others, 121 in all. You have to be sure that you don't have a name conflict. It's inconvenient when a name resolves to the wrong class. Beware of the asterisk. The asterisk is not a wildcard in the traditional sense. It won't insert intermediate names. An asterisk only marks the place where a class or interface name is inserted to build a full name. For example, this import statement works to find things in the AWT package, but not for things in a subpackage. For example, this class cannot have its name resolved with that import statement. It requires that you include the rest of the path name with the import statement like this. That's because all the compiler does is replace the asterisk with a class name and try it. The import statement has no effect on the running of your program. The import statement is only information for the compiler. Once the compiler has determined the full names of all the classes and interfaces, the import statement is thrown away. There is no runtime overhead whatsoever. There is one import statement that is always present by default. It is as if this import statement is at the top of every program. Every class and interface of the Java Lang package are always available by their short names. These are things like math and string and a number of errors and exceptions, 108 classes and interfaces in all. Okay, up until now I've been describing things that have been a part of the import statement since the very first days of Java. All this is still valid and still works the same as it always has, but in Java 5 something new was added. You can now import the static members of a class and refer to them as if they were members of the local class. For example, the byte class has a static method named valueOf that converts a string into a byte value. You've always been able to call that method this way. Now you can specify it on the import statement like this. Notice the presence of the static keyword on the import statement. Once you have this import statement in place, you can call the method this way. You can import all the static members of a class, the methods and the variables, by using an asterisk. I'll have some more to say about this later in the course, in the section on gotchas.